I am Shaul Amid, Professor EC Department, Seth Institute of Technology, Pullu Kariyapatti. In this session, we are going to discuss about Routh array. And first, I read the problem statement. The open loop transfer function of a unity feedback system is given by g of s equal to k into s plus 1 divided by s cube a square plus 2s plus 1. Determine the value of k and so that the system oscillate at a frequency of 2 radians per second. So, they have given a open loop transfer function. So, for that we have to find the stability of the system, and also we have to find the value of k for the system stability, and the given specification is the frequency is 2 radians per second. So, here this is open loop transfer function, and the feedback is unity. So, first step is to find the closed loop transfer function. The closed loop transfer function is given by C of s by R of s is equal to actually g of s divided by 1 plus g of s into h of s. Here h of s is equal to 1 because unity transfer function, unity feedback. So, I am just substituting the value of g of s in this equation. I get k into s plus 1 divided by s cube plus as square plus 2s plus 1 divided by 1 plus k into s plus 1 divided by s cube plus as square plus 2s plus 1. Now, we have to cross multiply this denominator. We get k into s plus 1 divided by s square plus as square plus 2s plus 1 divided by, when I cross multiply, s cube plus as square plus 2s plus 1 plus ks plus k divided by s cube plus as square plus 2s plus 1. I am just cancelling these two things. The remaining thing is k into s plus 1 divided by s cube plus as square plus 2s plus ks plus k plus 1. Now, I am just taking s outside and I am forming this equation. I get s cube plus as square plus 2k plus 1s plus k plus 1, this is constant. So, this is actually closed loop transfer function, that is C of s by R of s. Now, we have to take the characteristic equation. Characteristic equation is nothing but denominator of the closed loop transfer function is equal to 0, then it is called characteristic equation. So, I am just taking the denominator of the closed loop transfer function, I am equating this to 0. I get s cube plus a s square plus 2 plus ks plus k plus 1 is equal to 0. Now, I am going to form Routh array. I am taking the characteristic equation and I am just finding the highest power of the polynomial. This is 3, and the next highest power is 2. So, the highest polynomial is 3, power order is 3. Then the Routh array, which has only 4 rows, I am just forming the first row. I am forming the first row by taking the coefficient of odd order of the polynomial. So, odd order in the sense s cube and yes. So, coefficient of s cube is 1 and coefficient of s is 2 plus k. Now, I am taking the even order. So, s square and s power 0. S square coefficient is a and s power 0 coefficient is 1 plus k. Now, I am going to form the next row, that is s power 1 row. This can be formed by multiplying these two things, that is a and 2 plus k minus 1 into 1 plus k divided by this coefficient a. So, I get a into 2 plus k minus 1 plus k divided by a. Now we have to form the next row, that is s power 0. So this row can be formed by multiplying these two things, and a and here there is nothing, so I have to assume that 0. So I am just multiplying these two things divided by this coefficient, then I'll get s power 0 is equal to a into 2 plus k minus 1 plus k divided by a, and this 1 into 1 plus k, this one, minus a into 0, that is will become 0, divided by this coefficient. I get, when I cancel these two things, I will get 1 plus k. So I am just putting here, and this is the Routh array. Now now what I have to do is I have to find out the value of a and k for the given specification. The given specification is 2 radians per second. Okay, oscillating frequency is 2 radians per second. For that, I'm going to take auxiliary polynomial based on the second row, that is s square row. I get the auxiliary polynomial is a into s square plus 1 plus k is equal to 0. So this is purely based on this row. This row, the first coefficient, s square coefficient is a, and s power 0 coefficient is 1 plus k, which is equal to 0. So I am going to take this polynomial, and I am just separating here a s square and constant other side. So a s square is equal to minus 1 minus k. So a square is equal to minus 1 minus k. So s square is equal to, then I am just dividing right hand side by a. So minus 1 minus k divided by a. Now I am just taking minus outside, so I will get 1 plus k divided by a. Now I have to take square root of right hand side, so that I will get s. So s is equal to plus or minus square root of minus 1 plus k divided by a. So because of this minus, when we are taking square root of minus, we get j. So which is equal to plus or minus j square root of 1 plus k divided by a. So here the data given, that is oscillating frequency s is equal to, that is j omega, s is equal to j omega is equal to plus or minus 2 j2, that is omega is equal to 2 radians per second. Hence I am just substituting omega is equal to 2 in s is equal to j omega, plus or minus j omega I will get. So s is equal to plus or minus j2. Now I am going to equate this one and the previous one. I get, when I am equating, so plus or, there is no chain, plus or minus j is there. So this quantity square root of 1 plus k divided by a is equal to 2. So I am just taking square root of 1 plus k divided by a is equal to 2. So I am just removing the square by square root by squaring both sides. I will get 1 plus k divided by a is equal to 4. Now I am again cross multiplying, so I will get 1 plus k is equal to 4a. So k is equal to 4a minus 1. So I am just keeping this, and I am going to use the same term to find out the value of a and also k. Now I am going to take s power 1 row. So that is this row, that is s power 1 row. Here I have only one term, that is s power 1 into this term is equal to 0. So a into 2 plus k minus 1 plus k divided by a into s is equal to 0. Okay, so I'm just removing s, so I'll get this term is equal to 0. So when I am multiplying a with 0, I'll get a into 2 plus k minus 1 plus k is equal to 0. Now I'm just multiplying a inside the bracket. I get 2a plus ak minus 1 minus k is equal to 0. So I'm just separating k and a constant one side. So I'll get 2a minus 1 plus k into a minus 1 is equal to 0. Okay, now I'm going to substitute k is equal to 4a minus 1, that is previous finding. In this equation I get 2a minus 1 plus 4a minus 1 into a minus 1 is equal to 0. So I'm just simply multiplying these two terms. I get 4a square minus 4a minus a plus 1. So we have another two terms, 2a minus 1, which is equal to 0. So I'm just taking a square, a and constant. So I'll get 4a square, okay, 4a square minus, this is 5a minus 5a plus 2a 3a, and 1 cancel, constant cancel, which is equal to 0. So I get 4a square minus 3a is equal to 0. I am just taking a outside. I'll get 4a minus 3 is equal to 0. Definitely a cannot be 0. So I am just taking 4a minus 3 is equal to 0. So I am moving minus 3 right hand side. So I get 4a is equal to 3. So a is equal to 3 by 4. Now I am substituting a is equal to 3 by 4 in this equation, the previous finding. K is equal to 4a minus 1. When I am substituting 3 by 4 in this equation, 4 into 3 by 4 minus 1. So 4 cancel. I'll get 3 minus 1. So k is equal to 2. So we found a and also k. Okay, so that the system is stable. Okay, the conclusion is here, when the system oscillate at frequency of 2 radians per second, that is given frequency, the value of k is equal to 2, value of k is equal to 2, and also a is equal to 3 by 4. So for the given specification, we found that k is equal to 2 and also a is equal to 3 by 4. So this is the conclusion. Thank you very much. I'll come with another problem related to Routh array the next video. Thank you.